اللهم صل وسلم وبارك على حبيبنا ونبينا محمد عليه أفضل الصلاة وأتم التسليم. ربي اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. The title of our project is Artificial Neural Network, an application to load flow analysis of an interconnected system. The name of my colleagues who are involved in this SDB: Turki Nour, Jamil, Anas Harbi, Mohammed Alsheikh, Mohammed Jamal, and the supervisor, Dr. Arangari. The outline, which we're going to discuss throughout the presentation, is introduction, load flow analysis, biological neural network, artificial neural network, an application to load flow analysis of an interconnected system, and the conclusion. Introduction. First of all, in real system and in power system, we have thousands of buses, and these buses, most of them are load buses, and we have loads connected to those buses, and the load is changed depending on the load requirements each time. Once the load is changed, that means its voltage and its angle on that particular bus is change also. So this is an issue. So after that, some topic is coming on the engineering field, and electrical engineering field, which is called load flow analysis, or load flow, or solving load flow problems. Mainly, this load flow analysis has three conventional methods, which is when the active power and the reactive power on the load buses is changed, its voltage and its angle, by using the conventional method of load flow or solving load flow problems, you can get out the voltage and its angle at that particular bus when the load is changed, the active power and the reactive power. The three conventional methods are Gauss-Seidel iteration method, fast decoupled iteration method, and Newton-Raphson iteration method. Throughout our artificial neural network, we focus on solving load flow problems on Gauss-Seidel iteration method. In first generation, they were the engineers who are in the field. They were doing the calculations of solving load flow problems manually. The second generation, they use such a program like PTAB, MATLAB they use the conventional method and calculating the voltage and its angle once the load power is changed. In the third generation, they use ANN, which is artificial neural network. And this approach is basically you have an input and an output for a toolbox which is called ANN. The inputs will be active power and reactive power of that load bus. For example, if you consider this bus, we have active power and reactive power as an input, and we have the outputs of that. The output will be the voltage and its angle at that bus. Once we give the ANN the input, which is P and Q, and the output, which is voltage and its angle, and we train it, we process it for several training that lead, the ANN will recognize or will know the relationship between each input and each output. That's lead as a result. When you change the inputs, the output will be given when you change the inputs. And this is the main targets of using ANN. So once the P and Q change the system, we can get the voltage and angle, whether it's trained by the ANN or not, because it's known the relationship between each input and each output. And according to that, we can know the voltage and angle, we can calculate the power losses. So we can edit power losses and B demand, we can know the B generation. So we can schedule our generators, and we can maintain the whole system in a fraction of a second.
During presentation?
The important
means if we didn't train our ANN, okay, you use this word, so means it it will not decide, or it will decide on what?
As the losses. Check that the bus voltage magnitude remain close to the rated values. Check that the generator operates within specific real and reactive power limits. Check the transmission line and transformer are not overloaded. Calculate the voltage drop on each feeder. Planning for existing system modification for future expansion. And we get all these by once by if we just calculate the voltage at the beginning. Type of buses. We have three types of buses. Load buses, voltage control buses, slack or swing bus. Load buses, as we see there for the example that we have, load buses contain P and Q, active power and reactive power, and our C is voltage and its angle. Voltage control buses, we have the P and the V, the voltage, the active power and the voltage. We need to calculate the Q, the reactive power and its angle. Slack or swing bus, we have the voltage and its angle. We need to calculate active power and reactive power. And mainly our SDB will be on load buses. So we focus on these things on that slide because it's most of the system, 90% of the system is load buses.
Yes, okay. So means how you will know from P
connected to bus 1, and Y22 represent all admittance connected to bus 2, and Y33 all admittance connected Y33, and Y12 the admittance connected between Y1 and Y2 but in opposite in negative. Now, as you know, the apparent power will be equal P plus JQ and also V I conjugate. So we can put the equation 1 in equation 2 and we can get I will be equal P minus JQ over V conjugate. So this is the performance equation of N bus system. IB, for example, IB.
What is this?
For example, here IB, this IB will be equal YB VB plus YB2 VB2 until YBN VN. So we can say IB will be equal sigma when Q equal to 1 VBQ VQ plus VBB VB. So we can find the equation of voltage will be equal VB 1 over YBB BB minus JQB over BB conjugate, which is I, minus sigma of YBQ. So here we talk the voltage 1 as slack bus, the reference bus. We talk it always as a 1. And we can find open it, depending on it, the other voltage buses. So we take V2 as a 1 always, and V30 and V40 as a 1. And this the reference voltage. And so V31 will take the V21 here. And V41 we talk the V31. And so after different iteration, we will get and we will stop until the difference between the voltages equals 0 or almost 0.
Why you said V30 is equal to 1 and V40 is equal to 1? Is it?
Yes.
Why you did this?
Because we iterate the voltage until we get the actual voltage.
No, means in the V21 equation, why you take V30 and V40 is 1? Why? What is that one?
Now,
how many iterations it take to get
biological neural networks? First of all, the identification, construction, and functionality. Okay, what is a neuron? A neuron is are cells within the nervous system which produce electrochemical reaction to sending signal, receiving signal, and processing signal. The neurons, we have 4 types of neurons, which are sensory neurons, which related to our sense, smell, touch, feel, and another one which is motor neurons, which related to control our muscles, which has related with central nervous system, which is contains a brain and spinal cord. And the third one, interneuron, which is the interconnection between sensory neurons and motor neurons. And finally, we have brain neurons, which is the function of our hear and smell and these things. So it's in our brain. So it's very complicated thing. So here we have interneuron. We have here structure, dendrites. It's out as a tree, branch of the tree. Here the input signal are received from dendrites, and cell body, also it's called soma as a Greek word, which means process the signal, and then axon. Axon used to sending the signal to surrounding neurons. We have here synapse. Synapse actually is the joint between neurons. It's act as a resistance. As we more learn, it's decrease. So it's give us more improvement in our learning and fast learning. So now we are talking about the artificial neural network.
And engineer Hans is talk about load flow analysis, and engineer Turki is talk about biological neural network. For me, I will talk about the artificial neural network is similar to biological neural network. Okay? Okay, come in. Okay, we want to know what is the artificial neural network. Okay, artificial neural network is a smart technique for solving problem by constructing software that works like our brains. First of all, I want to talk about the history of artificial neural network. Okay, you know the first artificial neural network was made in 1943. At that time, the technology was not enough to make it better. Nowadays, by having the high knowledge, high technology and more knowledge, the artificial neural network become or developed and become more efficient. Artificial neural network is important. Okay? Neural network has huge ability to identify the complex data. Okay, that is too hard for human or other computers technique to understand and to make it simple. So the artificial neural network have adaptability, which ability to learn and to adjust by identifying the data that was given, and self-organization, which ability to organize and represent the data during learning time. About the modeling of artificial neural network, okay, these are process elements, okay, which each neuron, okay, can receive multiple input and deliver an output. The component of artificial neural network based on input and weight and output. For input, every input here has specific value and could be a pattern to the problem. And the key element of artificial neural network is a weight, okay, which is responsible for expressing relative strength of input signal, which transfer the data from input to the output, to the output which represents the solution to a problem. Finally, there is the application of artificial neural network, where we can use artificial neural network. Artificial neural network used in artificial intelligence, robot artificial intelligence, which ability to identify people attitude, and also used in camera, which ability to attitude people faces. These cameras are used in policy center, in shops, in public places. That was about artificial neural network. Thanks for listening. And our friend
Q1 up to Q60. Q60. This is the 30 bus, so the matrix will be 30 by 60, 1,800 matrix. We run each one Q1 and Q1, as I said in MATLAB, and we get voltage and its angle below it goes down. This is the voltage for Q1 and its angle goes
Can you
down.
click one of the cell? Click one of the cell. Click another cell. Click top. From where you are getting this voltage and angle.
We get it by MATLAB. We inject the Q1 and the Q1 in the MATLAB.
From the MATLAB.
Yes, we just take the Q1 and Q1.
Yeah, I mean CSL comma separated values, but where is that text? My point is, where is that MATLAB code? That's the point. You didn't got me. Where is that MATLAB code where you got this data? That's the point.
Okay. It's the modification too.
yeah, that's it.
Yes.
This is the bus data.
It's fine. Okay, carry on.
Okay. Should we explain about it or? This is the bus data. Okay. We have taken, first of all, we have taken the main data, which is available in the book, and we made up an increments of 0.2 for B2 and B3 up to B60 to complete the whole 60 pattern for P and Q. And we run each pattern to get its voltage and its angle, and we put it there in our data. So we have now our complete 60 pattern data, and based on it, we train and we give it an inputs and outputs, and it will be trained easily.
This code is given over here.
The codes,
The codes are given.
everything, everything includes.
خلاص ابدا يا تركي.
Now the other portion will be develop the artificial neural with the inputs and the outputs matrix. What's the artificial neural network is then get rid external data by being tested.
I want to literally speed it up because another group is waiting and your time is finished.
Okay. The standard 30 bus sample system, this is the bus that we are based on it. We made up load flow analysis and we trained the engine. The power flow data, this is the main data of the 30 bus, the 30 bus IEEE system. B and Q and the voltage and the bus code 1 is meaning slack, 2 voltage control bus and 0 load bus. This is developed the input matrix we have injected by the MATLAB. Bus data, we made up 60 pattern from 1 to
How
60.
you enter this data?
As shown here, we have a program. We take it from the Hadisadat book and we run it, and it shows the bus data. You need to change the bus data. First of all, it will give you the main data.
This
The
you
P1.
take from the book. The data?
Yes, it will give you the main data, P1 and Q1. So we made an increment of 0.2 until we reach 60 for active and reactive power. Once we run it, it goes more forward. Default the output matrix. Once we run it, it will give voltage magnitude, the angle, the power, and the Q. Okay? This is the input that we injected. This is the corresponding voltage and its angle.
This by the
And this is the number of buses, and this is the total.
I guess side of it.
By gas cycle method.
And you didn't wrote a program, M5, you didn't wrote for this. That's my point.
This the side method.
No, it's available. The program available in the book.
Okay.
Okay, we have taken it and maybe slightly changed for just some
What
such
that?
arrangements.
What you changed? That's the point. Means where is your means? Did you enter the data?
No. We have not put a new code.
No. Okay.
The code is the same.
Yeah. Yes,
Almost 99% it's the same in the book. We have not made up something.
Make your data here be
means the Gauss-Seidel method, I agree with you. You cannot program it. But where is your data? Where is your
IEEE 30 system.
30
Yeah,
by 30 buses.
30 bus system? So that data is yours, and it
Yeah,
is
so
you bring it
okay.
from somewhere
Okay.
and just put it in.
Okay.
it is meant to the data here we have this thing.
Okay. So open the XG.
Samir.
Now we will show you that.
First of all, you need MATLAB version with the latest version or the newest version with its toolbox, which called Deep Learning Toolbox, to generate. But first of all, before we generate, there are two methods of training, which are supervised and unsupervised. By me, the supervised learning, which means I give input and output to the artificial neural network during training. So first of all, we need to create our initial code. So by using our graphical user interface, by this command to generate our initial code. So here we are giving input data and output data, as you see. So here we have the initial training. The initial training has huge error, and we are going to talk about why it has huge error because of validation. Next. So now we are generate initial code by advanced script. So what we did actually, the graphical user interface, we have converted to initial code. But we have input data and output data. So we must convert them into a code or variable, x and t. So x means input, t means output. So after that we run program, and we can imagine that our model of NN contains two things, layers and table of training, which is by this code. The layers, what does it mean layers? Layers means holding the data during training. So during train, we need to catch up our data, and the train we have discussed about it. It's input and output. So our model has specific values or properties. We must modify on it because the error. So we have two properties, which is net train parameter, net division function. Net train parameter, which I tell the neural network, artificial neural network, to give me the highest efficiency. What time? How many time you take during training? And net division function, it is how the data are transferred during the lines. So it's bit by bit. Next slide. So executing learning, we are giving our input and output to do the training, as we see. So after we train, we can imagine our box like this. It has the train, the properties of NN, and layers and train. So now we are doing simulation, which is we are giving external data. You never saw it before. So when I give it the input data, he will predict the output by simulation. So finally we have the design, so which we convert our code into graphical user interface, which is friendly to user. And here our case, we have case 1, case 2, case 3. We have 3 cases. Here, what the promise of artificial neural networks? It's more faster than the conventional method of Gauss-Seidel, and also it can handle more pure system. So I can run the program to show you. This is our program.
we test the ANN by the extent of data that he never trained and he never saw it. Can we know the accuracy of it?
So his training on validation, as you see, is too much minimum because of the qualities. And we have here the performance of training. As the batteries are increased, the train will be give our best results. And we have input 3, so we can give percent before. And so
Time is finished. Yes. Another exam. Yes, brother, you can come. We are just checking the program. I'm in APX F10, so F11 is open. Maybe we'll shift to F11. You can come in 10 minutes, 5 minutes.
Conclusion. Samir? Conclusion.
we cannot show all the table because of the display revolution, but it's actually like this, similar to this. As you see, we have here the VNN, which is output of the neural, the artificial neural network, and our conventional voltage, Cassadin method, conventional method, and we have here the accuracy between them. It's almost 100%.
And that means the ANN is trained well.
Yes, that's me. Our artificial neural network are trained very well.
Okay. Finish. And a little bit faster because the teacher, another examiner came and we are just.
Okay. Conclusion. As we discussed, we have discussed load flow analysis, the methods, and gas-cycle methods, and we have discussed the biological neural network, the identification, construction, functionality. Also, we have discussed the artificial neural network, identification, artificial neural network importance, modeling, artificial neural network components, and their uses. The task for this semester we have done the developing the input power and active power and reactive power, and we developed the target output, which is voltage and its angle, and we do it in the artificial neural network. And once it's trained, the result was very acceptable, and we can apply it in the reality. Thank you for listening.
Okay.
Any questions?
Yeah. First of all, why gas